Once sea urchins get a hold on a reef and they collapse it, it's the most horrible sight you can imagine. It goes from beautiful kelp and weed to a surface that looks like the moon with black spiky things everywhere all over it.
We're 3 artists from Malakuta and we're about to experiment with sea urchins. So we've all got different backgrounds and we're going to see what we can do with these.
So we're experimenting in how to extract the colour from the urchins. We've been talking to some the synthetic biologists and we're trying to work with them to discover a way to extract the dye and then how to use the dye.
Oh, wow. I used the blender and blended some down too. So we can try the mortar and pestle. They fly out. That would be really time consuming, and that is probably actually 1/4 of an urchin. So crushing them down en masse, as opposed to grinding them, might be a good idea. I'm going to boil them and then I'm going to put these 5 pieces of fabric in, and I'm going to take one out every hour and then I can compare whether there was a colour difference, how long it was left in, or whether it ran out of colour at some stage. Good. It's gonna smell lovely. Gosh, Sarah, how would you describe this smell?
It's very
Sea themed smell.
It's not a horrible dead smell.
No.
It's just a strong. Every week of winter.
As you can see, the scientists have kitted me out with a home lab so that I can test things like acidity, alkalinity effects on the colours, different materials, silk, cotton, wool, and I can test things at constant temperatures because they've given me a water bath. So that's going to make a big difference. I've been testing some colours at 80 degrees, extracting at 80 degrees, and today I'm testing at 60 degrees. This is a cotton canvas for painting on, and we're getting this lovely pink colour out of boiling it with the urchin spines and shell. And then that's a colour fastness test, so we're seeing that if you put it in the north facing window, that was covered, getting fading through there. So it's not colour fast in light, but that was washed and it survived the washing process, so there's not much difference there. This was more of a painting experiment, so there's mixing it with like titanium white, which is very finely ground spine, and mixing with water, alcohol base, doing fine washes of it, and getting quite different purple colours. This one's mixed with acetone, it's very light. So I think there are some water-soluble parts in the sea urchin dye and some that may be able to be extracted with alcohol. That's watercolour paper that was boiled with it, so it's got a really strong colour. And then I moved on to doing some silk testing, and this was all done at 80 degrees with a new water bath. Since then I found out it's probably better to do it at 60 degrees, so today's experiments will all be done at 60 degrees using the water bath. Today I'll be testing these beakers, one with tank water in it and one with tap water in it, to see if it makes a difference to the shades that we're getting, the shades of purple. So these are spines only. It's about the same. And then using tank water. There we go. So this is filtered tap water. There we go. Sarah is back with us after being away in the UK for a bit, and we are making sea urchin dye with dried but not ground sea urchin spines, and we are going to start with washing them because we think that will get rid of the smelly aspects of them but not affect the dye. It's all fine. It all just breaks down. That much? Yep. 800 ml.
We're going to add the citric acid.
Yep, which breaks down the calcium carbonate. Yeah, that's about right.
See how that goes.
80 degrees. And there we go. Now we leave it for an hour in the water bath and then turn it off, and it sits overnight to break down. So this is what they are like after 24 hours, where we have separation of the dye at the top, and we can just pour that off and use it. And then this is the ground spines with citric acid, and it comes out a much darker purple colour and doesn't separate so much. And this is the colour from the pink dye on silk. These two have been tested for light fastness in the window, and you can see the line that they are not currently light fast, but we are working on that. With our final piece, we wanted to illustrate the difference between using a citric acid to extract a colour and using just the urchin in an alkaline water, which is Malakuta water is slightly alkaline. So 1/2 of this piece of fabric is dyed in the acidic, which should give us a beautiful pink, kind of almost the colour of a crab, or so somewhere between a pink and an orange. And then this side, which does not look so attractive, is randomly pink or brown, or it just depends on the urchins. So I'm going to untie it. It was tied just to give some variations in where the dye could get in. So I'm going to rinse it and untie it and reveal. Well, the other artists feel like we did make some headway into understanding how to extract the dye from sea urchins, and we found that adding citric acid made the most difference to colour. Our conclusion was, in terms of it being, say, a viable micro industry here, with more research and more understanding. I really do think it could be a byproduct of something that is currently being a pest here.